All right, guys and gals, we've spent our first two lessons of this unit looking at how to solve systems of equations by graphing. We looked at our second two sets of lessons rather, dealing with elimination. Today, we're going to put it all together in a simple review just to make sure we covered all of our bases and know what to do for each situation. So let's get started. Everything today is going to be examples, not too many talking points. We've already talked about how to do all of this. Today is just simply review. How do we get it done? If I go too fast as I'm graphing or doing things, please feel free to stop the video, work a problem out on your own, hit play, watch me work through it so that way you know how to get this done. Again, folks, this is one of those skills that next year in algebra you've got to know how to do. The better you can do now, the better next year will be for you. All right, so let's get started. Our first situation here with graphing, I noticed right away that my slopes are identical. Both of them are 1/2. I also noticed that the y-intercepts are different. Because of that, that means I'll end up with parallel lines and that there is no solution. All right, this isn't going to work. So now that I know that, cool, the pressure's off. Now it's just a matter of getting my lines graphed. I'm going to color code my lines for you today. So this top line will be blue. My bottom line will be red. That way, as you see me graphing, you know which one is which. And I'll try to keep that consistent all the way through for you. So let's start. -4 is where we'll begin. So all the way down here. I noticed that my grid is counting by ones in both directions, x and y. So counting the slope will be easy. So I'm going to count up 1 and then right 2. Up 1 and then right 2. To go to the left, we would do just the opposite, down and left instead of up and right. Cool. So now that I've got that down, we can go ahead and get our line drawn. Remember, use the straight edge. We want to be as precise as possible. All right, no freehanding it, please. This is not art class. All right, excellent. So now that we've got that done, let's try the second one. We'll start at 2, so that's all the way up here. Slope is the same. So again, up 1, right 2, up 1, right 2. And then to go the other direction, we'll do the opposite. So down and left, down and left. Cool. You notice what we've got are parallel lines. They do not cross. It's not a matter that they just don't cross in the grid that we can see. It's that indeed they are parallel. They're exactly that same distance all the way through. They will never cross. All right. There it is. All right, let's try the second one. So again, this top one will be blue, the bottom will be red, just so you can keep in line with the colors. So notice the slopes are different, the y-intercepts are different. So I am going to end up with truly two different situations here. We need to make certain that we get those exactly. So we'll start at 3. That's our intercept. So all the way up here, start at 3. Again, slope of 1/2. We just counted one like that a moment ago. So up 1, right 2, up 1, right 2. If you go the other direction, we'll just do the same thing, but opposite. So down and left, down and left. Same numbers though, 1 and 2. Let's graph it. Looks something like this. There we are. Put our arrows on there. Let's try the bottom one. Notice this time we're going to start at 1, so right here, and our slope is 3/2. So I'm going to count up 3, 1, 2, 3, and then right 2, 1, 2. Cool. We found that intersection point pretty quick. Let's get a few more points on there just to make it easier to graph. So instead of going up and right, we'll go down 3 and left 2, down 3 and left 2. That way we can continue that line. All right, well, now that we've got that done up, let's graph it. There we are. Make sure you put your arrows on there. And our point of intersection, remember we do need to write our solution. Looks like it's at the point 2, 4. So 2, 4. And we're done. Simple as that. Now notice this next one. A little bit more complicated. We've got our equations here in standard form as opposed to slope-intercept form, so we will need to rewrite those. So let's try that top one. Again, we'll let it be our blue equation. We'll do it over here. We've got plenty of space. So we have x subtract 4y equals -16. Again, don't drop your negative there. -16. Easy to do to drop negatives. First thing I need to get rid of is the x. So I'm going to go ahead and just subtract x on both sides. From there, we'll rewrite. Make sure you keep that negative. So -4y equals -x, subtract 16. Next, we need to divide by -4. We'll do that across the board. So divide everything by -4. And in this case, -4 divided by -4 is y. -1 divided by -4 would just be a positive 1/4. I'm not going to write that as a decimal. Remember, this is our slope. It's going to help us count to graph that line. So don't mess with that. Leave it alone. And then -16 divided by -4 is a positive 4. Cool. So there's our new equation. We'll go ahead and graph it. So we start at 4. And we're going to count up 1 and right 4. So up 1 and then right 4, already out of space, so we'll go the other direction. Down 1 and then left 4. And notice everything in line. If you're getting V patterns with your individual lines, then that means you're doing something wrong. More than likely, you're miscounting that slope. So be careful. Make sure you are drawing nice straight lines. Line everything up. Cool. So there's that top one. We'll go ahead and rewrite the bottom one next. We'll make that red. Draw a line here just to keep our work separate. So we've got 3x added to 2y equals negative 6. X's have to go first. Remember, we want y's to be all by themselves, so x needs to get out of there first. So we'll subtract 3x here on both sides. We'll end up with 2y equals negative 3x, subtract 6. Next, we'll divide everything by 2. We'll end up with y equals, notice this negative 3 over 2, do not change it. Leave it alone. That is our slope. It's going to help us count. Do not make it a decimal. It'll make your life much, much more difficult. From there, we'll take negative 6 and divide it by 2, so that's a negative 3. And ta-da, just like that, we've got what we need. So we'll start at negative 3 all the way down here. And we're going to count down 3 and right 2. So down, we can't. So remember, we'll do the opposite. So instead of down and right, we'll go up and left. So up 1, 2, 3, and then left 1, 2. Up 1, 2, 3, left 1, 2. You get the idea. Cool. There's our intersection point. We got to it there at the very last moment, but we got there nonetheless. Let's graph it. And then we can go ahead and write out our solution. So in this case, our solution looks like it's hitting at negative 4, 3. And there's graphing. Again, some of the hardest things is just making sure that you are counting correctly. And then if you do have to rewrite those equations, that you're doing so accurately. You're not dropping any negatives, that kind of thing. As soon as you do, you're going to be wrong. So just be careful. All right, well, let's start with elimination then. We said elimination was a little bit easier than graphing in the sense that we don't have to spend all of that time being exact with our graphs. The hard part is just making sure that we are paying attention to what we can eliminate and do so accurately. So let's look at our first one. I've got 3x subtract y equals negative 4 for the top, and I've got 2x added to y equals negative 1 on the bottom. And remember, we want to try to eliminate either the x or the y from both equations. In this case, it's already set up where I have a positive x up top and a negative x on top and a positive, oh good Lord, I cannot speak, a negative y up top and a positive y on the bottom. Goodness gracious. So I could go ahead and add my two equations together just as they are, and one of those variables will automatically eliminate, in this case, the y's. So let's add them together and see what we get. So 3x plus 2x is 5x. A negative 1 and a positive 1y, well, those eliminate, so nothing. And then a negative 4 and a negative 1 is a negative 5. So far, so good. To get x by itself, I'll divide everything by 5. And we end up with 1x equaling negative 1. Again, negative 5 divided by 5 is negative 1. So let's start writing that solution. So our solution in this case is negative 1, comma. Now we need the y. I always tell you to try to pick the number that's going to be the easiest to work with the various equation you're going to pick. Personally, I think it's going to be easier to try that second one. I think it's just going to be a little more obvious for us to work with. So we'll change colors here to show our work for y. Let's see, we'll do it over here. I'm going to pick that bottom equation, though you can pick the top and it'll work just as well. So I've got 2x added a negative 1. So we'll add our negative 1 equals negative 1. All right, so here we go. I got to get rid of this negative 1 because remember this is a two-step equation. So to get rid of negative 1, I will add 1 to both sides. All right, that gives me 2x. Negative 1 and positive 1 zero out, so who cares? Negative 1 and positive 1 zero out, so we'll write a 0 here. Well, what number multiplied by 2 would give me a 0? Well, that's pretty simple. Oh, look what I did. I put that in for y. Oh, good Lord. Let's try it again. Again, it's that kind of stuff that's going to mess you up, folks. Daggone it, I keep messing this up. Let's try again. 2x. I did it again. Mercy. I'm going to switch colors. Maybe that's the issue. Here we go. Let's try green. 2 times negative 1. Goodness. There we go. Plus y equals, what do we have here? -1. There we go. My goodness. All right, so let's multiply that out. -2 plus y equals -1. What a day. All right, so we got to get that y by itself. I've got a -2 to get rid of, so I'm going to add 2 on both sides. There we go. And we end up with y equals, because those cancel out, -1 and +2 is a +1. And there is my answer at last. Oh, have mercy. So again, some pitfalls. Don't do something silly like your math teacher did. Make certain that whatever you find, so in this case x, that you plug it in for x. And again, pay attention to things like your negatives. If you don't, it's going to cause you problems. All right, let's try this next one. Hopefully you recognize from this one that I've got x subtract 2y, x subtract 2y. These are the same, identical in every way. So if these two are indeed the same, they should be equal. Problem is, we're told that they're not, and that's weird. So if you have a case like that, where in this case, we're told that the same value equals two different results, this is what we're going to call a no solution situation. So let me show you why this is a no solution scenario. What I'm going to do is I'm going to multiply the bottom one here by a -1. So I'm going to take this entire situation and multiply it by a -1. So if I do that, we'll keep the top equation. So let's rewrite it. Top equation stays, so that x minus 2y equals 6 stays. For this bottom equation, -x, positive 2y, and then a positive 6. Now we can add them together. Well, watch what happens. Positive x and negative x zeros out. Positive 2 and -2y zero out. 6 and 6 give me 12. In other words, I end up with 0 equals 12. That doesn't work. So if we end up with something that's obviously false, so in this case, obviously 0 does not equal 12, we have a no solution scenario. Simple as that. And again, I spotted that early on, so I didn't technically have to do all this work. If one side is identical and the other side is something totally different, well, then we have a no solution scenario. So you should be able to spot those very, very quickly. All right, let's try another one. All right, well, with this one, I notice I've got a couple of different options. I've got 6x, 2y, and 4. I've got 3x, 1y, and 2. I noticed that I could go ahead and multiply everything by a -2 here on the bottom, and then the x's would cancel because that would be a -6. I could also, well, notice that -2 would also work here. Well, that's kind of weird. Let's see what happens. I'm going to multiply everything down here by a -2, and we'll see what falls out. So that top equation is going to stay the same. It's 6x, it's 2y, it's 4. All right. This bottom equation, however, is going to change. -2 and 3 is -6x. -2 and y is -2y. -2 and 2 is -4. Those look almost identical because they are. If I multiplied this bottom one by a -1, they would be the same. And watch what happens. If I add them together, I get 0. I get 0. I get 0. In other words, 0 equals 0. These two equations are the same. If that happens, that means I have infinitely many solutions. In other words, if I were to graph these two, if we were to go back to this first page, take those equations, rewrite them, and graph them, they would be on the same line. So, for example, if I drew just a real quick XY axis here, they might look something like this. All right, and be the same line. So infinitely many solutions. All right, well, let's try one last one here. Oh, notice we've got a lot of craziness going on here. I've got x and 17x, so I could multiply that top by -17 and eliminate, but multiplying by 17 is going to make these numbers really big. So let's hold off on that. I've got a -6y and a -2y. I could multiply this top one by a -3. That would keep the numbers smaller and help those eliminate. So I think that's what I'm going to do. So I'm going to multiply this top by -3, and we'll see what happens. So let's write it out. So the top equation will change, -3x, a positive 6y, because notice negative times negative is positive, and then a negative times negative also positive, so in this case positive 30. All right, this bottom equation won't change. So the 17x stays, the -6y stays, the 54 stays. All right, well, let's add them up. -3, positive 17, well, that is 14x. Positive 6, -6, cool, those cancel out. That leaves me with, what is that, 84. Cool, all right. So we're going to take that, and then we'll divide everything by 41, no, not 41, 14. Goodness gracious, don't make any more silly mistakes. So we'll divide everything by 14. Cool. We'll get x equals, if we take 84 and divide it by 14, we should get 6. Yes, 6 indeed. Cool. So now that we've got that, I'm going to write it up here. Our ordered pair is going to start off with a 6. So now I need to figure out which of these equations do I want to use to try to tackle y. Well, I think in this case, it's going to be easier to use the top equation. The numbers are smaller. Here, if I'm going to have to take 6 and multiply it by 17, I don't really want to do that. So let's try it here. So I'm going to take 6 and drop it in for x. Hopefully I can do it better than I did that first one. So 6 instead of x, -2y, and -10. All right. Well, let's go ahead. I'm going to subtract 6 from both sides. So that gives me, keep that negative, so -2y equals -16. That looks good. We'll divide everything by -2. Move that up there a little bit. And then we'll get y equals 8. Cool. So there's my solution at the 0.68. So if we were to graph these, they would cross somewhere up there in that first quadrant. All right. One more to do. In this case, our word problem. So let's read over it quick. Remember, when we create a word problem to get that system, we need 2 different equations from 2 different points of view, and that'll help us solve our system. So it says Brenda bought 8 eating utensils for a total of $28. Eating utensils are things like forks, spoons, knives, that kind of thing. Speaking of which, it says spoons cost $4, forks cost $3. How many of each eating utensil did she buy? All right. Well, notice, I've got 2 things we're keeping up with. My first is simply the total number of utensils. So I'm going to write that down. One of my equations is going to relay the total, and I'm going to do that in green. Another situation that we're keeping up with is overall cost. So I'm going to write that down, cost, and I'm going to do that in red, just to keep the 2 separate. So let's look at our total equation. If I'm dealing with spoons and forks, well, I'm going to let spoons be x, and I'm going to let forks be y. All right, we need to make sure that we specify what our variables are worth. All right, that's called defining the variable. So I'll let x be the number of spoons, we'll let y be the number of forks. Cool. So if I take the number of spoons, so, I want to do that in green. There we go. So if I take the number of spoons, add the number of forks, we were told that we should have 8 utensils in total. Cool, there it is. All right, well, let's look at cost. We're told that each spoon is $4 each. So I could write this as 4 for every spoon, adding on for 3 for every fork, for a grand total of $28. So there's my system. The question I have to ask myself now is, what do I want to change? Well, I noticed that this top one is kind of ripe for changing. Notice we've got 3s and 4s we can make it. I'm going to multiply the top equation by a -3. That'll let me get rid of the y and then find x. All right, so let's rewrite it. So we'll get -3x, a -3y, and then a -24. Cool, that looks good. The bottom is unchanged, so I'm going to rewrite it here as 4x added to 3y equals 28. So let's add these up and see what we get. Well, -3 added to 4 is 1x, so that's great. We've already eliminated the coefficients there. +3 and -3 zero out. This is turning out better than I had hoped. And a -24 and a +28, well, that is 4. So it looks like for our solution, we have a 4 for the x. In other words, we have 4 spoons. I'm going to take that number and plug it back in. I'm going to use this original green equation. So if I know there were 4 spoons added on to how many forks for 8 utensils, well, that's pretty easy. Y also has to be 4. So we'll plug that in and work it out. So the meaning of my situation here is simple. Brenda bought 4 spoons and 4 forks. Simple as that. All right. So again, today in class, we'll be doing more of the same. We'll spend some time practicing our graphing. We'll spend some time practicing our eliminations. And we'll also spend some time with some word problems. That way you can go over them and be clear of what's happening. If you have any questions or concerns, please bring them with you to class, and we'll talk about it when I see you next. Have a good day, folks.